All right, guys, we're moving on to 10.5, where we're going to be talking about trig and area. Thought before we moved on to rhombus's and kites that we would go ahead and do this, but since we're talking about triangles again, our mission here today is I can utilize trigonometry to find the area of a triangle. So you remember from talking about area of a triangle that typically when we had a triangle that we had to take the base, right? And we had to multiply that times the perpendicular height. Again, our formula for the area of a triangle, because it is half of a square, is the area equals 1/2 the base times the height. But what could you do if you did not know what the height was? Is there a way possibly that you could use some other method, maybe that we've used in the times past, maybe even something like trigonometry, to help you to find the area of a triangle? Well, as a matter of fact, there's got to be some special circumstances that are happening with the triangle, but we'll get into that here in just a second. But let me just go ahead and draw out another triangle here really quick, and I'm going to go ahead and label this triangle ABC. We'll call it triangle ABC, and I'm going to call the sides across from each angle the lowercase letter of that. So in other words, angle B is right here. So I'm going to call this side B, little b. Across from side A, we'll call that little a, and across from side, or angle C, sorry, we'll call that side little c. So again, we've got this triangle here, but again, we could kind of go ahead and symbolize, I guess, and say that this could be my base, but I still lack a perpendicular height, okay? So let's just, and again, we're trying to look at this in a general sense. So let's think about the fact that, okay, if I did make a perpendicular height here, I don't really know what that is, but is there a way for me to maybe try to figure out what the H is? Because the H is the critical part, right? I've already got B here. B is part of my formula right here, but I need to figure out what this H is. So let's just think about this from the perspective of trigonometry. And again, you remember SOHCAHTOA, all right? It may be something you've tried to blot out of your memory, but hopefully not. The SOH, you remember this first part of the mnemonic stands for sine equals opposite over hypotenuse. And we're not going to go through every one of them, but I just want you to think about this one, sine equals opposite over hypotenuse. Well, if you notice here, I have, a matter of fact, a right triangle that's kind of been created over here on this left-hand side. So I want you to think for just a minute that if I used even this trig function, I could probably try to figure out some things. For example, sine of A, the ratio for that would be opposite over hypotenuse. Well, opposite of angle A is actually side H in this smaller triangle. So that would be H over the hypotenuse, which again, we're focusing on this little green right triangle over here on the left. The hypotenuse of this one would actually be C. So I want you to just look at that for just a second and think for yourself, well, wait a minute, I could probably try to solve this for H, right? Because H right now is being divided by C. And so in order to get rid of C, to get C out of the way and isolate this variable H, which is really what my goal is, well, in order to do that, I need to multiply by C over here, which means if I do it to one side, I have to do it to the other side. And so when I do that, this is going to cancel out. And lo and behold, I'm going to get that H equals C times sine of A. Okay. Now you might think, well, that's not that spectacular. We just kind of moved some things around, and we did figure out, we did get H by itself, right? That was kind of the goal, is to get H by itself. But how in the world does that help me? Well, think for just a minute again that our formula for a triangle is area equals 1/2 the base times the height. Well, I've already got B right here, but what I needed was H. Well, now I have a value for H, okay? H equals this. So think about how that we could rewrite this formula as being area equals 1/2 the base. Instead of the height, I can multiply it times this value for H, which is C sine of A. And lo and behold, ladies and gentlemen, we have a formula now that we could use to find the area of this triangle based on the area formula that we already had, but now we're using trigonometry to help us figure out what H is. Well, what would be the required pieces for this? Well, again, I already had the B, so that was already there. but I'm also going to have the C, which is here, and I'm going to have angle A, right, in order for me to be able to figure this out. So think about really what you have to have. You have to have this side length, you have to have this angle, and you have to have this side length, okay? So really what I have to have in order to use trigonometry to find the area of a triangle is I have to have side, angle, side, okay? As long as I have side, angle, side, in other words, I have an angle that is between two sides, as long as I have that situation, then I can actually use trigonometry to help me find the area of a triangle. So let's look at a couple of examples. It won't take but just a couple of these for you to get the hang of this. But let's just look at a couple of examples here. And let's say that this side is 8 centimeters and this side is 7 centimeters, and this angle right here in between is 115 degrees, okay? So quite simply, all I have to do with this is I use my formula, area equals 1/2 BC sine of A, okay? So again, what are my parts of my equation? I've got to have two sides and I've got to have an angle in between. So area equals 1/2. B or C, it doesn't really matter because there's a commutative property. There's multiplication between all of these things. So it doesn't matter if I call this B or the other one C. It really doesn't make any difference because there's still multiplication there. But we'll call 8 centimeters B. So we'll substitute in our 8 there. We'll substitute in our 7 for C. And then we have sine of angle A, and it tells us that angle A is 115 degrees. So quite literally, folks, you could go over to one of your best friends by now, probably, your Desmos scientific calculator. Let me get rid of my spot. And I'm going to go ahead and do 1 divided by 2, or 1/2, times 8 times 7 times sine of 115 degrees. And notice, ladies and gentlemen, what answer it gives me, 25.37. Just make sure this is in degree mode, and it should be automatically. But notice it's 25.37. If I rounded to the nearest tenth, I would end up with 25.4. So my area is 25.4 square centimeters, okay? Just that easily, you can find the area of that triangle without ever really knowing what the height is, as long as you have side, angle, side. Okay, so now let's look at number two. Number two, and we'll draw this one out just a little bit different, just to make sure that you understand that it doesn't really matter how it's drawn as long as you have the conditions. So 30 feet and 25 feet, and then we're going to say this angle here is 124 degrees. And again, notice I have a side, I have an angle, and I have another side. So I do, in fact, have side, angle, side, which means that I can use my formula. Area equals 1/2 B times C times sine of A. And again, it doesn't matter which one's which because of the commutative property. So we'll call this one B, we'll call this one C. So substitute 25 in for B, substitute 30 in for C. And sine, remember your angle always goes with your trig function, so the angle is 124 degrees. And quite simply, I come back over to Desmos again, and again put in my fraction, 1 divided by 2 times 25 times 30 times sine of 124 degrees. And voila, there's my answer. 310.88. Again, this 8 would tell that other 8 to go up. So I would end up with area equal 310.9 feet squared. Okay? So again, hopefully this has been helpful to you. Maybe something you've never seen before, probably not. But again, it's really not that difficult. It's just understanding that this is the formula that you can use as long as you have side, angle, side in any triangle whatsoever. It doesn't matter whether it's right triangle or what. You can actually use this formula to be able to find the area of a triangle as long as it has side, angle, side. Okay? So hopefully this has been helpful. And if you need any help, make sure to reach out to us.